Hi everyone, today we're going to be doing a simple problem using the torsion formula. You can find this in section 5.2 of the Hibbler textbook. If you haven't watched the lecture slides yet, please do so before watching this video in order for you to have a full understanding of the content. So here you can already see I have steps written out. I'm just going to take you through it using this problem. So here we go. The problem states that the solid shaft and tube shown in figures 5-A are made of material having an allowable shear stress of 75 megapascals. Determine the maximum torque that can be applied to each cross-section and show the stress acting on a small element of material at point A of the shaft and points B and C of the tube. So, in order to first start this problem, we're going to start with a polar moment of inertia equation in which J equals pi over 2 times c to the power of 4, in which c is the radius. So, doing this, we're going to have pi over 2 times 0.1 to the power of 4 equals 0.1571 times 10 to the negative 3 meters to the fourth. As you can see, we did a unit conversion here to get into meters. Now we're going to do the same thing for the tube, but we're going to be subtracting the two radiuses, or radii, in order to compute this. So we're going to have 0.1 to the power of 4, subtract 0.075 to the power of 4 times pi over 2. This results in 0.1074 times 10 to the negative 3 meters to the fourth. Alright, since we have our polar moment of inertia, now we can move to the shear stress formula, Tc over J. But we're solving for T, which is the internal torque. So we're going to have to rearrange the equation, and in doing so we get the shear stress multiplied by the polar moment of inertia over the radius, 0.1. This results into, well, here we're just going to plug in the values. We're going to have 75 times 10 to the negative 6 times 0.1571 times 10 to the negative 3, all over 0.1. The result is 118 kilonewton meters. This is the maximum internal torque of the shaft. We're going to do the same thing for the tube, rearrange the equation, input the values, and we get 80.5 kilonewton meters. Now, since we have our T value, the internal torque, we're just going to solve for the stress. So all we're going to do is plug in our values. We're going to use the lower torque here, the lower maximum torque. Put it here. We're going to have 80.5 times 10 to the 3 multiplied by 0.075, which is the internal radius, all over 0.1074 times 10 to the negative 3. This results in a shear stress of 56.2 megapascals. So as you see, this was a simple problem just displaying basic knowledge of the concept at hand. Hopefully this helped, and I will be posting more videos in the future to help you develop a full understanding of this topic. Thank you and have a good day.